students. So in today's video, let us go for the next long answer from current electricity. State Kirchhoff's laws for an electrical network. Using these laws, deduce the condition for balance in a Wheatstone bridge. So for this, first you have to write Kirchhoff's first and second law. So Kirchhoff's first law, we call it as current law. Okay, KCL, Kirchhoff current law. So it says that at any junction, now if this is the junction, the currents, the sum of currents entering the junction is equal to sum of currents leaving the junction. So I1 is entering the junction, I3 is leaving the junction. So that is the summation of I is equal to 0. Next, Kirchhoff's second law. We also call it as Kirchhoff voltage law or loop law. It says that the potential differences across all the elements of the loop will be 0, or algebraic sum of charges in potential around any closed loop involving the resistors and cells. Here I said elements, no? What elements? Resistors and cells is 0. Okay. Now, let us move to Wheatstone bridge. This is the circuit, okay, of a Wheatstone bridge. It has 4 resistors, 1, 2, 3, 4, R1, R2, R3, R4. Alright. Across AC, we connected battery. So it is called as battery arm. Across BD, we connected galvanometer. So it is called as galvanometer arm. So now galvanometer is used to detect the current. If these 4 resistors are adjusted in such a way that when the current passing through galvanometer is 0, that is Ig equal to 0, then we say that Wheatstone bridge is balanced. Now, first let us apply Kirchhoff first law. Okay. So, let us apply the Kirchhoff first law at junction B. So, I1 is moving towards the junction. I3 is moving away from the junction. See the arrow mark. So, first law says that the currents moving towards the junction is equal to currents moving away from the junction. So, I1 equal to I3. Put it as equation 1. Similarly, applying the Kirchhoff's first law at D. Okay, at D. Now, I2 is moving towards the junction. I4 is moving away from the junction. See the arrow marks. I4 moving away from the junction. I2 moving towards the junction D. So, the currents moving towards the junction will be equal to currents moving away from the junction. I2 equal to I4. Right? Put it as equation 2. Now, next, let us apply Kirchhoff's second law. That is the voltage law to loop A, B, D, A. A, B, D, A. So, in such a way, I am drawing the arrows. A to B, B to D, D to A. This is the path we are following. A, B, D, A. Okay. So, now, when we apply this to this particular loop, what we will write? First AB. So, along AB, I1 R1 voltage is there or potential drop I1 R1. Now see, path direction and current I1 direction both are same. Path direction, that is A to B. Now current I1 direction is also A to B. Both are same. When both are same, current and path direction are same, then we take I1 R1 with negative sign. Okay, we take I1 R1 with negative sign. Now next, again B to D, galvanometer current. Okay, so plus IG. Again D to A. Now see, path is from D to A. Current direction is from C. I2 is in this direction. A to D. Means path and current direction are opposite to each other. So we take this with positive sign. So I2 R2. Now the potential drop I2 R2 along the resistor R2. Okay. I2 R2 will be equal to 0 as per second law. Now galvanometer, it is a balanced bridge. So Ig will be 0. So minus I1 R1 plus I2 R2 equal to 0. Or I1 R1 equal to I2 R2. Right? Or I1 by I2 is equal to R2 by R1. Right? This equation. I1 by I2 equal to R2 by R1. Okay, clear? Now next, let us apply Kirchhoff voltage law to, now let us apply to CBDC. CBDC loop. C. CBDC. This is the path direction I drawed. So first let us write the potential across R3 resistor. So what will be that? I3 R3. The path direction, I3 current direction are opposite to each other. So I3 R3 is taken with positive sign. Next, plus IG. Next, again D to C, no. Current direction I4, path direction are in same direction. So we take I4 R4 with a negative sign, that is equal to 0. But this is balanced bridge. So galvanometer current will be 0. Okay. So 0 minus I4 R4 equal to 0. Or I3 R3 equal to I4 R4. Or I3 by I4 is equal to R4 by R3. Okay. Now next, from equations 1 and 2, I3 is equal to I1. I4 is equal to I2. Right? Let us substitute here. I3 is equal to I1. I4 is equal to I2. We are using equation 1 and 2. These two equations. In place of I3, I substituted I1. In place of I4, I substituted I2. That is equal to R4, R3. Put it as equation 3. Now, equation 4. Now, from 3 and 4, what we will get? I1 by I2 is equal to R2 by R1 here. I1 by I2 equal to R4 by R3 here. So, we get R2 by R1 is equal to R4 by R3. Okay. This we call it as balance condition of Wheatstone bridge. Okay. Or principle of Wheatstone bridge. So this is the next long answer from current electricity. So for this, practice well. 2 points for current loop. So current law, there is no problem. Easily you can write the current law. At B, currents going towards the junction is equal to away from the junction. So easily you will write I1 equal to I3. And at D, I2 equal to I4 you will write. So where you will face the problem? At a voltage loop. Just remember two things, that when path and current are in a same direction, take IR with negative sign, right? If they are in opposite direction, take IR with positive sign. So first I took A, B, D, A. My path is from A to B, B to D, D to A. So here current direction, path direction same. So I took I1, R1 with negative sign. And here current direction, path direction opposite. So I took I2, R2 with positive direction sign. Similarly, next loop, what I took? CBDC. CBDC. So C to B. Current and path direction are opposite. So I took I3, R3 with positive direction sign. And here current and path direction are same. So I took I4, R4 with negative sign. If you can remember these small thing, this point, then easily opposite means logically opposite means actually we will take negative, but here we are taking positive. Same means actually we will take positive, but here we are taking negative. At least remember in such a way and write down this. And IG will be 0 because this is balanced bridge. And find out the formula. So if you like my video, share it, subscribe it. Okay, thank you for watching my channel Reshma Physics.